In some ways, your daily life contains many of the qualities of good detective story. Unanswered questions and unexplained problems challenge your thoughts and actions all the time. And so, you often act like a good detective. You discover places to go with friends and family. You learn about people who come from different cultures. You explore and gather evidence about the world around you. Like a good detective, you often try to make sense out of a series of clues and find meaning in seemingly unrelated observations. Chemists, too, are good detectives. They gather evidence, analyze clues, follow their hunches, and make predictions. One of the most successful detective stories in the history of chemistry is the development of the periodic table of the elements. The periodic table of the elements represents a system of classifying or logically grouping all of the known elements. The arrangement of the elements in the periodic table was a milestone in the history of chemistry because it brought order to what had seemed to be a collection of thousands of unrelated facts. And it did something even more important. It helped chemists predict the existence of elements that had yet to be discovered. The detective in this fascinating story was the Russian chemist Dmitri Mendeleev. The evidence he uncovered consisted of a huge collection of facts about the 63 elements that had been discovered by the mid-1800s. His clues were the physical and chemical properties of these elements. Based on these properties, it seemed clear to Mendeleev that some elements were similar to others. For example, sodium and potassium were both soft, silver-white metals that reacted violently with water. Mendeleev had a hunch that there had to be some order or relationship among all the elements. He was convinced that he could find a way to arrange the elements so that those with similar properties were grouped together. But what could the pattern of this arrangement be? In his search for the pattern, Mendeleev first decided to organize his data. He did this by making a card for each of the known elements. On the card, he wrote the properties of each element. Some of the properties he included were atomic mass, density, color, and melting point. He also included the element's valence or bonding power. Atoms form bonds with other atoms during chemical reactions, processes in which atoms join together to form molecules. When atoms form bonds, they either lose electrons, gain electrons, or share electrons. The valence or valence number of an element indicates the number of electrons that will be lost, gained, or shared in the bonding process. Always look for a pattern. Mendeleev arranged the cards in order of increasing atomic mass. If he started with lithium, the next element would be beryllium. Then would come boron, carbon, nitrogen, oxygen, and fluorine. With the cards arranged in this order, Mendeleev noticed the startling pattern of the valences. 1, 2, 3, 4, 3, 2, 1. 7 elements in a row, and the pattern of valences repeated itself. As he arranged all 63 cards in order of atomic mass, Mendeleev saw the same pattern of rises and falls of valence again and again. He also saw something even more remarkable. When the elements were arranged in this way, they fell into columns, one under the other. All the elements in a column had the same balance. All the elements in a column showed similar physical and chemical properties. It was obvious to Mendeleev that the properties of the elements recurred at regular intervals. In Mendeleev's words, he found that the properties of the elements were periodic functions of their atomic masses. When used this way, the word periodic means repeating according to some pattern. The days of the week are periodic because every 7 days the pattern recurs. The months of the year are periodic because they also occur in a regular, repeating pattern. The notes of the musical scale are periodic, repeating a pattern with every 8th note. In fact, you may already understand the word periodic from your familiarity with the word periodical. Sometimes magazines and newspapers are called periodical. Their appearance on a newsstand, in a library, or at your home occurs according to a recognized repeating pattern. You probably know when your favorite periodical is due to appear and eagerly anticipate its arrival. Animals and plants also exhibit periodic behaviors. Birds fly south when the winter's cold limits their food supply, and they return north the following spring when warmth signals an abundance of food. Can you think of other examples of periodic occurrences? Mendeleev designed a periodic table in which the elements were arranged in order of increasing atomic mass. Confident of the accuracy of his discovery, he left spaces in the table in order to make the known elements fit into the proper columns. Then he boldly announced that the empty spaces would be filled with elements that were not yet discovered. Indeed, he even went so far as to predict the physical and chemical properties of the unknown elements. He based his predictions on the properties of the elements above and below and to the left and right of the spaces in the table. Was he correct? Yes, in fact, he was. 3 of the unknown elements were discovered and placed in their correct positions in the periodic table during his lifetime. And the properties of the newly discovered elements were in close agreement with Mendeleev's predictions. You can see for yourself how well Mendeleev's predictions were fulfilled by looking at the figure above 6-4. Despite the importance of Mendeleev's work, his periodic table was not perfect. When the elements were arranged in order of increasing atomic mass, several elements appeared to be misplaced in terms of their properties. Mendeleev assumed that this was because the atomic masses of these elements had been incorrectly measured. Yet, new measurements reconfirmed the original masses. What could be the problem? It was not until 50 years after Mendeleev had developed his periodic table that the answer to the problem became clear. It was then that the British scientist Henry Moseley determined for the first time the atomic numbers of the elements. As you will recall, the atomic number of an element is the number of protons in the nucleus of each atom of that element. The discovery of atomic numbers led to an important change in Mendeleev's periodic table. It turns out that when the elements are arranged in order of increasing atomic number, rather than increasing atomic mass, elements with similar physical and chemical properties fall into place without exception. Thus, Mendeleev's periodic table was replaced by the modern periodic table. The periodic law forms the basis of the modern periodic table.